So we started discussing number 3. In part A, opposite sides are congruent. I know the diagonal is common to these two triangles. Hence, they are congruent, hence I find that it's a parallelogram. Number B, actually some students have troubles. If these two opposite angles are equal, say they are x and y, then I know what's x plus y, right?
Yeah, 180 degree, right?
Because 2x plus y is 360, it means they are supplementary to each other. It means, again, it's a parallelogram. And number C, this is a big question to us. We have two opposite angles are equal, two opposite sides are equal.
So if you still continue to draw the diagonal like you draw earlier, then it becomes side, and angle. So it does not guarantee one.
There's no congruent steering for that,
right? So that's the issue, right? So actually this problem gives us a little hint how to construct things like this. You have a 45 degree, right? So this goes to here, right? That makes sense?
So we would like to construct a 45 degree angle somewhere here.
Right. So the easiest way is we go what?
Minus 15, 0. This is equal to this.
Right.
And this point PQR, let's say S.
So now this guy has length what? 15 root 2, right?
Yeah, this is 45, and this is 15 root 2.
Which is same as this one.
So we know that these two lengths are equal. Our S is equal to PQ. And if
we have a pair of opposite angles are the same, and a pair of the sides are the same. So clearly, this is clearly not a parallelogram, right? So this gives us an idea as why this is actually wrong. So this relates to the what? Side angle side are not congruent.
SSA does not imply congruency.
So this question is another very tricky version of illustrating this fact, right? What's the normal version to show SSA is not what? Congruent?
Okay, so we see here are two examples of why SSA does not actually imply congruence. In the first one, we have this large triangle, and inside there's a smaller isosceles triangle here. So these two angles are equal, these two sides are equal. And then if we look at the red triangle and the blue triangle, they have a side, and an angle. Here's the same side, same second side, and the same angle, but they're clearly not congruent triangles. One is inside the other. And then the second example, we have this wide isosceles triangle. So these two angles and these two sides are equal. And then we draw the segment in the middle that's not perpendicular. So we see here that if we look at them, we have side, angle, and then the same side, same second side, same angle. And clearly, again, they're not congruent.
This one you construct it almost like this. You fix this angle first and this side, right? And then you have a compass. You can draw another third side, and you intersect this length what? Twice. So you produce two triangles. And this one is also, you already have a pair of sides and an angle. So anything in between gives you the third, this second side, and they are clearly not congruent, right? So two different, very quick structures to see why SSA doesn't work. Actually, they are quite related because of what? If I swing this triangle to that side, and then I stack these two triangles in a different way, so this becomes that.
Right. So we have, this is the blue one, right, and then the red one now comes over here.
Right.
And they line up to form this line along the bottom because this angle here is 180 minus that.
Right.
So the same thing here.
In fact, a pretty interesting fact that says that SSA is 9 times. So if they're not congruent, then one pair of corresponding angles is complementary.
Yeah.
Supplementary, right? Okay. So there are only at most two, right? So where did this come from? This comes from which structure? That's why I said it's all about how to ask questions, right? If this is too common, you just twist a little bit, and then people start to say, oh, I don't know what to do. But you look at this. This picture clearly reduced to here. Look, all this is about different playing. When we are young, we play what? Plywood, right? You can form different shapes. So over here we see why this two plywood can make a triangle like this. You just put it outside instead of overlap them. So how do I go from this plywood, two pieces, to this?
Well, you can flip one of them to your
Right. We never are restricted to make this into a triangle, right? So if I flip this side, flip this piece up here, then I get this one. So this one is basically coming from what? This guy, I flip them. So this one comes from this shape. If I turn this around, I got this. So this is actually a trapezoid, two congruent pieces, isosceles trapezoid, right? So it's just like a different way of asking a question, but already can throw people off because we don't really see the real inside of the question, right? Okay, and that's exactly we need to improve on when we study math.